welcome to the first episode of Tooling Time with John Vincent. My name is Carter. I'm the marketing coordinator here at Swoosh. And this is the first episode of this new show we're trying. It's a manufacturing show dealing with the CAM module in NX. It'll be every other Thursday here on YouTube. We're also streaming to our Twitch channel, Swoosh Tech TV. And I'm here with the host of it, John. How you doing, John?
I'm doing great. How are you doing, Carter?
I'm good. Where are you joining us from?
I'm outside of Milwaukee, Wisconsin.
Okay, great. I'm here at the Swoosh headquarters in St. Louis. So, can you tell us a little bit about what people can expect from this Tooling Time show, and maybe like where the idea came from?
Yeah, for sure. So really, this idea came out of some discussions with various customers of ours. Obviously, in this line of work, we do a lot of demonstrations of software functionality and ways that users can apply the software. But it seemed like what was lacking was a lot of just the understanding the hands-on issues that are encountered kind of in a day-to-day basis from CNC programmers out there. So we wanted to start this little series, and we're going to bounce back and forth between doing some how-to topics similar to what we're doing today, where we're going to look at creating custom manufacturing templates, and then using some of these things, like in this case, we're going to use templates down the road in creating programs for programming some part files to see how you can really use everything end to end within Siemens NX.
Okay, great. And what are you going to be looking at? Oh, sorry, I was muted. What are we going to be looking at in this first episode?
So in this first episode, we're really going to be focusing on creating custom manufacturing templates. And so what that means to me is we're going to be able to create our own setup templates for individual machine types or individual processes. So we can set things like we can load our machine tools into the setup for simulation purposes. We can establish common fixturing, typical operations tooling, all inside of our templates. So this data is set up and ready for us to go instead of always loading the same information or recreating the same templates over and over, really just to streamline our process.
Okay, awesome. I'll hand it over to you. I will say, if you're not already subscribed to our YouTube channel or following us on Twitch, go ahead and do that now, and click the little bell icon next to that button so you'll be notified for the next episode, which will be 2 weeks from today. And of course, we're watching the comment session. If you have any questions during this, we'll just address them as they come in. All right.
All right, Carter. It looks like you have to give me permissions to share my screen.
That I do. Do you have it now?
Yes, we're good now.
Okay.
All right. So what I'm going to do is just start by kind of reviewing out of the box what templates we have available and kind of what they look like. Now I'm working in NX 1953, which is the most current version of the software. But right now, if I were to go to File, New, and look at our manufacturing templates, and I come to the Manufacturing tab, I can see we have a number of out-of-the-box templates here that Siemens provides to us. Here's some just kind of generic setup templates based on what type of a process are you going to be utilizing. And if we go down below it, there's some more custom templates that have some of the out-of-the-box simulation machines attached to them. Inside of any of these, there's really no data as far as tooling or fixturing. However, we can really create our own based on what our individual company needs. So what we're going to look at today is going through, and we're actually going to leave all the out-of-the-box templates alone, but we'll create a separate tab for our custom templates. So we'll have an additional tab here that we'll call Swoosh Manufacturing, and then we'll go through and create a template that we can use later on down the line for programming part files that fit into that kind of envelope. And in this example today, what we're really going to look at is we're going to set up a horizontal machine, or I'm sorry, a vertical machine with a rotary table. And we're going to set it up with a couple vices for doing flip operations, which I think are very typical on a 3-axis machine. So I'm going to go ahead and start diving into the content here of how do you actually go about doing this. So the first step we're going to look at is creating an additional tab in this file new menu. And if I pull up an file explorer window here, this is the default location. Let me actually back up here for our templates. We're in C, Program Files, Siemens, NX 1953. As I said, that's what we're using in this example. And inside of the mock directory, there's a folder called Templates. Inside of this folder, there's a number of different part files. We'll see some JPEGs, different images. But what we're really looking for here are these PAX files. I'll just sort by type. And there's a handful of different PAX files. And what we can do is really copy one of these existing PAX files, and each one of these files is driving one of the tabs on our file new menu. So in the case of the manufacturing template that we looked at, that is being driven by this UGS_manufacturing_templates. So I'm simply just going to go ahead and copy this existing PAX file and paste it in to the same folder location. And I'm going to rename this. I'm just going to call it Swoosh manufacturing templates. I think that's fine. I'll go ahead and do that. And so these PAX files they're really XML files. So I'm going to go ahead and just edit this with Notepad++. Really any text editor would be fine, but I prefer Notepad++. And just to do a quick overview of what we're looking at here. Obviously, this is a pretty long file, a lot of content here. But in short, this first section, it's kind of the presentation section. This is controlling the information that's displayed on that tab. So here I'm going to rename some things here. We'll say Swoosh manufacturing templates. And actually, I need to back out. I need to change my properties. These files are read-only from the standard installation. So I'm just going to go ahead and change that read-only status. And we'll open with Notepad++ again. And I'm just going to start changing this first line, this presentation line. I'm going to rename this Swoosh manufacturing templates. And again, the file new tab name, I'll change it to Swoosh manufacturing. So in this case, what we're really doing is this is going to be the name that's displayed on our tab. So I'll just quickly press save and I'll go into NX and we can show this. Now I'm going to have to go into a part file real quick just to, let's see here. If I go file new is what I'm looking for. Right now, if we look through these tabs, nothing has changed so far. We always need to either relaunch the software, or we can also open up an existing file. And if we go and jump into manufacturing, we can reread our configuration file, and that'll work out for us too. And we'll just go ahead and reread that file. And now when I go to File New, we should see, yeah, I guess we're not seeing it. Let me go ahead and relaunch the software real quick. So through this process, you'll do this a number of times where you're making some changes, close down the software, open it back up. It's going to reread any files and changes that you've made. So you will end up doing that a few times. All right, so now we can see we have our tab under this file new. We have our Swoosh manufacturing, but we didn't change any of the template files that were inside of here. So that's kind of our next step here. Now we want to start modifying what content is available to us in our custom tab. So we're going to jump back to that XML file and kind of continue our way down and to understand what's going on here. We have these series of palette entries. And if you're not familiar with XML language, that's okay. It's not a big deal. Each one of these palette entries corresponds to a specific template. Inside of here, we're just setting some things such as the name of the template, some of the presentation information. This is what you'll actually see in the dialogue, or in the description is in the little window that shows some more information about your template, as well as information about here's where we can specify a JPEG to show a little preview image, and so on and so forth. There's just various settings in here. But what's important for us right now is I'm just going to go ahead and delete all of these palette entries, with the exception of one, and that's the one I'm going to start modifying for the custom template we will be making. All right, so now we just have one palette entry at this point in time, and I'm going to rename this, and I'll call it Swoosh. In this case, we're going to be building a VF2 Haas machine. So I'll just call it Swoosh VF2. That's good enough for us. And in this presentation line, we have a couple things to fill out. The name. This is going to be the name of my template. Again, I'm going to call it Swoosh VF2, and I'll say general setup. And description, I'll leave this description as is for right now. Once we get this editing done and we go back into NX, we'll take a look and really associate where these different settings are visible and what they affect in the dialogue themselves. Likewise, I'm not going to bother changing this image. We'll just utilize this standard JPEG image for right now. But you can certainly change that if you want to have a machine logo or company logos. You can have all that be displayed in the NX session. So that's good. We've set our presentation information, and the next area is this object data. So inside of this object data, we're going to be telling it, one, where is our actual template file? We have to have a PRT file that we're going to use for loading any fixturing templates or tooling, machine configurations inside of. So we don't have this. This is going to be the template that we will be making, but I'm going to go ahead and just create a name for this right now. And for the sake of this this demo, I'm going to call it Swoosh VF2 HRT210. This is, let's spell that right. There is a rotary on this machine that we're going to be using. Haas's HRT210 rotary table. And so that's what I'm going to call my part file. Currently, we have not made it. That'll be in our next steps here. And if we look, this string right here, this is a environment variable pointing to a specific directory. So let me bring up my Windows Explorer here. I'm going to go to the mock directory, navigate to resource, template part, and you'll see we have 3 folders inside of here. Images is just used to house any images that you want to share or show in your dialogues. So really we have to know, are we going to be working with an English part or a metric part? For this example, I'm going to be using English. So the environment variable for this path, I just need to change here. This is going to be English. And so then I will be creating my Swoosh VF2 HRT210 part file in that folder location. Next, we're specifying a CAM configuration file. So you might be used to these already, that you go ahead and select them if you jump into the manufacturing application. in a non-master model mode, you have to always choose a configuration file. Otherwise, out of the box, all the templates have various configuration files assigned to them, and I'm going to use Cam General for now. That's kind of the most generic configuration file out of the box, and we'll just stick with that. And again, I have to specify, am I working in metric or English? So in 2 locations here, I just have to change my library class path and my units to English. And a second time. All right, so here we have it. We have our palette entry has been modified for our template that we will be creating. So I'm going to go ahead and save this file right now. And we're going to jump in to starting the creation of an actual template file. So this is the out-of-box location. Again, mock resource, template part, English folder. And I'm just going to grab one of the common templates that's used out of the box. In this case, I'm going to select the mill planar assembly. And I'll just, again, copy and paste this part file here and rename it. Now I'm going to rename it to this swoosh underscore VF2 underscore HRT210 that we established in our PAX file. And here we go. Let's copy that one more time. And there we go. We have it pasted. So, all right, that's the next step. We have a template file now. We haven't really done anything with it, but that'll be our next steps. So let's see here. There we are, swoosh VF2, HRT210. I just want to check the properties on this file. Yep, I'm going to have to uncheck read only, so we have the ability to modify that now. And I'll go ahead and press OK. And I'm going to go ahead and close my XML file. We shouldn't need this again. I do have to, once again, launch close NX and relaunch it. So I'm going to go ahead and do that right now. And now just for verifying this step, the changes we've made so far, again, come to File, New, and we'll look at our Swoosh Manufacturing tab. And when I select the relationship of all, we no longer have that default list of all those templates in here. We just have our Swoosh VF2 general setup. And you can see in this dialog, this preview on the right-hand side, this is where if you specified a different JPEG or some sort of image file, this is where you would be able to see the preview. And then your information down below, the name of the file, description. If you might remember, we left this 2.5D milling and hole making operation description in there. We could have certainly changed that to whatever made sense for our application. But we now have our template set up, ready for modifications to use for our custom approach. But before we get into that, we're going to take just a brief break here, and I'm going to throw it back to Carter and get a drink of water, and then we'll continue on with the demonstration. What we see a lot of time with customers is people just don't know what exists out there, what capabilities are in the software. And that's one thing that I think we do a really good job with in our training courses, is the ability to kind of shed light on a lot of the different topics and functionality that are available within the software. And I think it's also kind of a responsibility that we have as trainers is really challenging the customers to maybe look at things from a different perspective or some different approaches. Throughout all of our lessons, we go back and forth between lecture and hands-on activities and live demos So it's not all lumped, lecturing for 8 hours a day. We try to maintain the virtual classes in much the same way that we would if we were in person. I'm John Vincent. I'm an applications engineer specializing in the CAM module, manufacturing module at Swoosh Technologies.
All right, welcome back to Tooling Time. Before I hand it back on over to John, I want to talk a little bit about some of the classes that you're teaching coming up. First of all, what class would something like you're showing here, the manufacturing templates, like what class would you cover that in?
Well, we have a CAM customization class, and in addition to topics like this, where we're creating custom templates, we also cover more information about editing libraries, tooling information, a lot of the tools that programmers use on a day-to-day basis. A little bit more from the systems side as opposed to hands-on manufacturing of parts.
Okay, awesome. I wanted to show just where people can find some more information about that. So if you're on our website under this training tab, you can click classroom schedule. There's that one you were just talking about, the manufacturing customization class. And then I also wanted to highlight, we have one coming up on February 16th, a multi-axis machining class. What kind of things do you cover in that class?
So multi-axis is related to any 4 and 5 axis type of toolpath programming. So we're really covering a lot of the variable axis. We now have variable axis roughing strategies in the software. That's quite new to us, that we can utilize a lot of the adaptive tool paths, as well as the whole host of semi-finishing and finishing of multi-axis applications for doing mold and die type work, or any surfacing that is required of complex parts.
All right, awesome. I know we have a couple people already registered for that, but there are 7 seats left, and obviously right now everything is virtual, so you can join from your home or from your office, wherever you're working from at the moment. How would you say that virtual training is going, John?
I think the virtual training has gone great. Obviously, we were kind of forced into it the past year, but we've really learned a lot, and the amount of material that can be covered in the same amount of time or less time even, it just seems that we're more efficient in the classes, and there's definitely really no limitations as far as being able to teach in that environment. We can always share screens of all students and share information quite easily. So it's really been not a problem at all for us.
Yeah, and I will say that the students still like to receive like the physical course manual, so we still do ship that out so you can have it there on your desk as you're going through the class on Zoom or Teams or whatever your preferred streaming service is. And it's also a nice little reference guide to keep after the class of nice physical student manual. So I think at this point I'll pass it back on over to you for the rest of the show.
All right, sounds good. So what we're going to do now is actually open up that part file that we created. That's going to be our template, and we're going to start making some modifications. So I'll go ahead and just open this up. And right now, the only thing that's in here, remember, we just copied an existing template. And there's only one part file in here right now, mill planer target. And I'm going to have to go through and change my assembly load options real quick here. As saved, I'm going to have to point to the folder location here. So let me do this real briefly. And what this is, when you do a file new, this is your target geometry that allows you to, when you reference another part file, NX actually switches out the geometry, kind of does a replace component. And so that's all this folder, this file is just this target body that when you do a file new with referencing a component, it replaces your geometry with this part file. So that's okay. We have that set up now. I'm going to go ahead and save this file. I'll change my load options back to as saved. And now what we're going to start doing is going through and modifying the content of this template. So I'm going to start with bringing in a machine tool in this case. So I want to bring in this Haas machine kit that I've built. So I'm just going to go ahead here in the Operation Navigator on the machine tool view, and I'm going to retrieve this machine from my library. And in this case, I can just come down to my list, find the machine that I'm using, and say OK. It's going to pop up a dialog that we can bring in our machine tool. We can use assembly constraints. We can use part mount junction. Not important for what we're doing right now because we're going to be moving our components around. So here we are, loaded my machine tool. Now, if you use simulation and you go through and program your part every time and then load the machine into that environment, again, this is just another way to handle that. So you're not always loading that machine every time. It'll just be there for you in your template. Okay, so we have our machine tool. You can see the component that comes in here. So I'm going to start with I'm going to throw an assembly constraint on this just to fix this. I kind of want to have a solid reference before I start bringing in some other components. In this case, I'm going to put a couple vices on this table that I can do a flip operation. So I'm going to go to my reuse library, and I have a vice assembly that I like to use. So I'm just going to throw that in my part file. And I'm going to constrain that to my machine table at this point in time. So all the normal assembly constraints are available here. There's nothing really special or different when you're setting up a template. All the standard CAD functionality or functionality that you might be used to in CAM will still be available. Tire assembly, yep, that's good. And so I'm just going to continue positioning this vice. And we'll do, like I said, we'll put two vices on the table. I'm just going to center this on my table for the time being. And I'll drag that over, maybe do a distance constraint from the side of the vice to the edge of the table. Well, let's see here. We'll just position it for our example. We'll do 3 inches off the edge of the table. And I'll bring another vice in right now. Same thing. I'm just going to load it from the reuse library. Reuse library is another topic. If you haven't played around with that or started experimenting, great way, particularly for us on the CAM side, to handle things like fixturing, clamps, hold downs, any kind of riser blocks for holding on your parts. You want to check all the clearances to all this information. Very easy method for loading and reusing that data, as opposed to going through and loading them as components every time and rebuilding assemblies. You can see I have my vice assembly set up here with typical jaws that I'll use. And it's very minimal as far as the time spent setting these part files up. And I'm just going to put one last constraint here, just putting these two vices some given distance apart, and we'll say OK. All right, so now we have our machine tool. We have the vices that I keep on this machine at any given point in time. We need to do a couple other things here. I'm going to move this mill planar target. So I'm just going to move this part file so it's roughly centered in a vice. It's not too important. Again, this is geometry that gets replaced when you start a template. So it's really up to you, whether you want to apply constraints or just kind of have this roughly in location. I like to just kind of roughly position it. And then once the actual component is brought into our file, once I am starting the setup, then I go through and constrain the part and the jaws and all that kind of stuff. We'll see that in future episodes. So now this template is intended to show a flip operation. So I want to have my setup for both op1 and op2 ready to go as soon as I create this file. So I'm going to load a second instance of this mill planar target. So we'll go add a new component. And let's just go ahead and drop it in here at some given point. And I'm going to start applying some constraints just to, in this case, I'll align the bottom surface of this target with the top surface of the original. And let's see, if we flip 180 degrees, these two surfaces would still be aligned. So we'll position that, and same thing, I'll come through and select this second instance. And I'll just move this one instance of this component kind of roughly to the center location of the second vise. All right, so here you can see this is representing op1 and then flipped over 180 degrees for op2. We do have to do one little change to the second instance of the part. If I right click on the original component, go down to our properties, we can look, there's an attribute here called cam component type, and the value is target. We need to assign that attribute to the second instance of this component. So I'm going to go ahead and just copy that attribute name. We'll go to the attributes for the second component and type in this information. Target is the value. So now you can see both parts had cam component type target for an attribute. When we go and use this template, that attribute is what's going to tell NX, replace my reference geometry with these target bodies, or vice versa, replace these target bodies with my reference geometry. All right, so that's good. That's our parts are set up, and I'm happy leaving my vices set up like this because I like to do my constraints for my actual parts once I create my setup. But perhaps I'd like to do a couple operations. I don't need to program anything. I just like to prep that and have that content in my template. So I'm going to go ahead and create, just for this demo, I'm going to create a facing operation. We'll assign that I want it to belong to the workpiece group. I'm going to select mill finish because I'm just going to deck off my parts to finish height and say OK. So you can see we have first operation, and maybe I'll throw a drilling operation in here too. So I'll come and select a hole making operation and just use a standard drilling operation. I haven't brought in any tools yet, so that's what I'm going to do now. I'm going to grab a couple tools from the library. So I'll go to create tool, search throughout my tooling library, and let's see here. I'm just going to grab, there's a 3-inch face mill. I'll add that to my setup, as well as I'll reference another tool. And drilling. And let's search now for a 1/2-inch drill. We got 3 of them, and I'll just go ahead and grab this first instance of that tool. Here's a little warning. It's no big deal. We'll go into the tool machine tool view. In this case, it was trying to load these tools into pockets. I'll just attach them to the spindle itself. And I want to assign, in this case, we have a drill. Let's see, this is our face mill, actually. No, this is the drill. So I'm going to go ahead and assign my drilling operation under my drilling tool and my facing operation to the face mill. So each of these tools, as well as the operation, we need to specify that, we want these to be made available when I'm using this part file as a template. So I'm just going to highlight both of the tools. And if I right click, come down to object, template settings, I just want to toggle on both of these template settings. This is just telling NX, if the parent file is used, create these tools or these operations right along with it. So I'm going to do the same thing for my operations here. And toggle both of these on. All right. So now we've gone through, we've created, we've added our machine tool, we've positioned our target bodies, and we've created a couple operations and tooling. So that's great. That's a great starting point. So I'll go ahead and save this file again. And I'm going to close it at this point in time. So really our PAX file has been created, and we've created our custom template for this machine and this particular setup. So what we need to do now is kind of load a file and show how this works. So here I just have some little widget. It's just a block with chamfer and a hole going through it. But this could be a part file that you've received from your engineering department or from a customer. Again, doesn't matter whether it's created in NX originally or brought in as a parasolid or step file. But we're going to go ahead and say that we are ready to create our setup for this part file. So this is kind of the typical state where a programmer would start his operations. You open this part file, and we're going to come to File, New, and we're going to go ahead and take a look at our Swoosh manufacturing template, and we're going to select that. And you can see by default, the relationship, because I had a part file open, is set to reference existing part. And NX here down on the very bottom, it already selected my Model 1. That's the name of that little widget that I made as my part to reference. So I'm going to go ahead and just say OK. And we'll see NX is going to load my template. And so we'll have our machine tool. We'll have our fixturing. We'll have our parts positioned in our file. So here you can see our parts. One is with the op 1 facing up. Op 2's got the part flipped around. That's the way we position that target body. And now we would be able to proceed going through and constrain our jaws to show what the machine setup would look like. So not only do we have our geometry really set up pretty much ready to go for us, if we go and look at our operation navigator here, we'll see those operations that we created already are in our template file. Same for the tooling. And so you can see how you would really be able to go through and for typical setups, have your normal tooling, your residential tooling, or your typical fixturing in your part file and ready to really minimize the amount of time you're spending doing any kind of the prep work for creating your program. So there you have it. We created our custom PAX file and a custom template to really be able to minimize your amount of time spent programming. And I think in the next episode, we'll certainly keep building off of this example that we have. And we're going to start looking at programming parts using templates like this and how quickly we can start building our company setup and just be able to minimize the time programmers are spending their time on this type of work.
Awesome. Thanks, John. So if you want to see that next portion of this demo, that'll be 2 weeks from today. You can go ahead and subscribe to our YouTube channel or our Twitch and turn on notifications for the channel, and you should be notified. We also post all these links to LinkedIn where you'll see our blogs and other things from our application engineers at Swoosh. So thanks so much, John, and I guess I'll see you in a couple weeks.
Yeah, thank you, Carter. It was fun.
See you guys.